This is an example from section 8.4, which is a test of a hypothesis about a population mean, and it's a large sample, so we'll be using the Z statistic. And the example states, for the sample body temperatures of 106 adults, the mean temperature was found to be 98.2. I always like to kind of underline numbers that I might need. And this was the sample mean. Assume the sample is a simple random sample and that the population standard deviation is somehow known to be 0.62. Use a 0.05 significance level, that's our alpha, to test the common belief that the mean body temperature of adults is equal to 98.6, which is what we've always based our temperature and thermometer readings on. Find using a test statistic and also the p-value to form your conclusion. Guys, we're going to do this one by hand, and I'm also going to show you how to do your calculator, and it's going to simplify your life immensely. But I think it's important that you see it both ways. The previous video kind of walked through the 8 steps, and instead of having to write the conclusion, I typed it out. So spoiler alert there. So steps 1 through 3, basically, you need to decide what they're claiming. So the claim is that the mean body temperature is equal to 98.6. That's the claim. That's what we're trying to test. So this is where it might get a little tricky. We're looking is equal to 98 point, not less than, not greater than, is equal to. So the opposite of that would be that the mean is not equal to 98.6. So now you have to determine which is your null hypothesis and which is your alternative hypothesis. Now remember, the null hypothesis always has the equality in it. So our null hypothesis is going to be there because it has the equal sign, and our alternative hypothesis is going to be that the mean is not equal to 98.6. Step 4, I've got right here, our alpha has been designed in this experiment. It's been told to us at 0.05. Using the table that I've given you in the notes, the standard critical value for 0.05 is negative 1.96, and it's going to be positive 1.96, because if you look at this in the curve, we're looking to test the mean 98.6. We're testing whether it is or is not. So it's going to be a two-tailed test. 1.96 here, 1.96 here. Now, if they said it is greater than or less than, then we would have a one-tailed test. But this is equal and not equal, so both ends of the curve make us reject. All right, step 6 is where you find your test statistic. And using the equation, our test statistic is going to be our sample mean, 98.2, minus the mean that we're testing against, 98.6, divided by the standard deviation, divided by the square root of n. N is 106 adults. So your equation is sample standard deviation, the mean that sample mean that you're testing, the sample mean, the mean that you're testing against, standard deviation, square root of n, all which was given to us. And you'll find that the test statistic is negative 6.64. Now, negative 6.64 happens somewhere in here in the rejection region. So our conclusion here is going to be to reject. And so what I did is wrote our conclusion, and I've given you some ideas on how to do that. There's sufficient evidence to reject the claim that the mean temperature of healthy adults is actually 98.6. There's sufficient evidence to conclude that the mean body temperature of all healthy adults differs. We didn't say what it's going to be, less or greater. We're just saying there's evidence here that it is different than 98.6. Now, let me show you on the calculator, TI-83, how to do this. turn it on. You go to Stat, over to Test. We're going to do a z-test. We have a large sample, and we're going to hit Enter. We are going to hit Statistics here because we have the mean, standard deviation. We have this information. If you have a data list, you can enter it into L1, L2, L3, and use data in that case. So here, the mean that we're testing against is 98.6. Standard deviation was given as 0.62. Our sample mean is 98.2. Our number is 106. We're testing that the alternative hypothesis is that it's not equal. We'll go down and calculate. Boom, done. This is our z-test. It shows our test statistic at negative 6.64, which is what we found by hand. And here it gives you the p-value. I'm going to put this in green on the board. The p-value for this is 3.10 times 10 to the negative 11th. It's very, very small. And what you do here with the p-value is you compare it to alpha. Now the p-value is less than alpha, you reject. If your p-value is greater than alpha, you accept. You fail to reject. Okay, so I will do some more examples, but this is the z-test for hypothesis testing.